Hi all. Today we are going to see mesh analysis. Mesh analysis, here what we do is we are considering each loop as a mesh or each closed circuit as a loop or a mesh. Okay, so in each loop or mesh, we are assuming that current is flowing through that closed circuit and we will name the currents as our wish I1, I2, I3, whichever loop we gave I1, that is I1 current flowing through that loop, and I2, I3, and depending upon the number of loops the current will also increase. And the next thing which you need to know is that while passing the current through an element, there will be some voltage drop. So we are considering, what we are considering over here is Kirchhoff voltage law, or we used to say the KVL. KVL method is applied on the mesh analysis. So for each loop, we will consider the KVL, that is total voltage is equal to 0, or supply voltage is equal to total drop in the closed circuit. That is the technique which we are using in the mesh analysis. So here a question is given: what is power loss in the 10 ohm resistor in the network shown? Use mesh analysis, and we are provided with a network. You can see. So in the network, in the question, I'm considering the uh, closed loop containing 8 ohm, 3 ohm, and 15 voltage as per my first loop, and the current flowing through is assumed as I1. And the second case, second loop I'm considering is the loop which is a closed loop which contains a 5 ohm, 2 ohm, and 3 ohm. And the third loop, and the current flowing through that second loop is I2. And the third loop is the closed circuit containing 10 ohm, 5 ohm, and 8 ohm, and that current flowing through that mesh or loop is named as I3. Now what I'm going to do is I'm just applying the KVL rule. So while applying the KVL rule in the first loop, what will be the answer? You can imagine what is the answer. Okay. So for the first loop, loop one, or name, we will provide some names for this. So let this be A, B, C, D, E, and F. So for loop, the loop we are considering is AEF. That is the first loop. Okay, loop one. So for the first loop, the KVL equation comes like this: 8 into I1. Then here always what we consider is that current is entering through the plus and current is leaving in the minus. For those നമുക്ക് resistor case we don't have any positive or negative for, but for the calculation, easy calculation, we are considering that the entering point is plus and the leaving point is minus. So അത് നമ്മൾ ഏത് ലൂപ്പാണോ കൺസിഡർ ചെയ്യുന്നത്, if you are considering the first loop, the current corresponds to the first loop entering as plus, leaving as minus, and other currents relating at that time is in the different manner. Like if we the case while considering the 8 ohm, what happens here is that current I1 is going from here to here, so it is plus. That is why here it is plus. Now in the same 8 ohm, current I3 is also flowing. You can see like this. Current I3 is also flowing like this. So the I3 current is entering from minus and leaving at plus. So 8 I3. Always remember, if you are considering the first loop, that current will be entering through plus and leaving through minus. All others will be according to this notation. Okay, so remember that. Now, so 8 minus 8i3 plus, what is next? Plus 3i1 minus 3i2. Now, in the case of voltage source, current is entering. Here, entering is minus. Voltage source notations will be given in the question. Adanansariche, write the equation. So here it is entering from minus. So minus 15 is equal to 0, or this is equal to 8i minus 8i3 plus 3i2, sorry, i1 minus 3i2 is equal to 15. I took the constant right side. Now I can simplify or minimize this as 8, sorry, 8 plus 3, that is 11 I1, then minus 3 I2 minus 8 I3 is equal to 15. This will be my first equation. Now, loop 1 work. Now consider the case of loop 2. What will be loop 2? Loop 2 will be the mesh E, F and D, or EDF. EDF, that is better because the current I is flowing in the clockwise direction, so EDF. So in this case, in mesh EDF or mesh or loop 2, the equations will be like this: 3I2 and the current. Here we are considering that the current is flowing like this clockwise, so the current entering in 3 ohm through plus and leaving in minus. Our notations we are planning, okay? So don't get confused. Always for the loop, corresponding current will be entering from plus and leaving in minus in case of a resistor. Voltage source, if it is given some sign, notations follow that. Okay, so here also plus minus plus minus. So earlier I1 in the case of the 3 ohmile the plus minus was like this, മോളിൽ plus താഴെ minus ആയിരുന്നു. So but for correspondingly for the I2 current, plus is below and minus is in the upper side. Okay, so ഇനി I1 ന്റെ കേസ് 3 ഓമിനെ കൺസിഡർ ചെയ്യുമ്പോൾ I1 നേരത്തെ അതേ ഡയറക്ഷൻ ആണ്, പക്ഷേ സെക്കൻഡ് ലൂപ്പിനെ കറസ്പോണ്ടിങ് ചെയ്യുമ്പോൾ the I1 is entering through minus in case of second loop and I2 is entering through the plus in case of second loop or second loop equation. So 3I2 minus 3I1 plus 5I2 minus 5I3 plus 2I2 is equal to 0, and you can write in a simplified manner like this: minus 3I1 plus 8I2, not 8, 10I2, 10I2 minus 8I3, sorry, 5I3 is equal to 0, and this is your second equation. Now what is the next? Now we have the third equation in which the third loop in which the current I3 is flowing. The loop is ABCD. So now we are going to consider the third loop. So in third loop it is named as ABCD. So the in that case current is entering in the 8 ohm like this. അല്ലേ, നമ്മുടെ I3 വരുന്നത് അതിൻ്റെ ആ ലൂപ്പിലെ ക്ലോക്ക് വൈസ്. സോ ഇങ്ങനെയാണ് I3 ഫ്ലോ ചെയ്യുന്നത്. സോ 8 ohmൽ എവിടെ എൻ്റർ ചെയ്യുന്നു അവിടെ we will put plus and leaving point is minus. 10 ohmൽ here plus minus and here it is plus and minus. The black represents the I3 current flow and the red represents other currents. Okay, so the equation for here is like this: we have 10I3, 10I3, then plus, what about 5 ohm? It is 5I3 and current I2 is opposite to that direction, so minus 5I2 plus 8I3 minus 8I1 is equal to 0, and simplifying it I can get, we have minus 8I1 plus we have I2, it is minus, so minus 5I2 plus I think is 10 plus 5 plus 8, that is 23 I3. So 23 I3 is equal to 0. This is the third equation. Now what to do? Now we have to simplify the three equations. Then we will get the equation, no, the value for I1, I2 and I3. And here we are asked to find the power loss in the 10 ohm. So 10 ohm the current flowing through 10 ohm is just I3 alone. So I3 now we can simplify this using calculator. You can just substitute the equations for calculator in the equations. So you will get directly I1, I2, I3 and find out the I3 value. I am going to represent here a matrix method in which I can just calculate by using the calculator is the most easiest way, Here sometimes we will the question will be like to find the equation, so find the value using the matrix method or Cramer's rule. So I'm representing here the Cramer's rule or matrix method to solve these equations. So here I have written all the three equations one by one. Now what I'm going to do is I'm just making this as a matrix. So this is how to write the matrix form. Now here what I did is from the first equation I have taken the coefficients of I1, I2, I3. So 11 minus 3 minus 8 is the first row. Second row is minus 3, 10 minus 5. Third row is minus 8 minus 5, 23. And the next matrix is the column matrix, that is the coefficients which have to be found out or which is multiplied with the coefficients it's taken the values the I1, I2, I3 is written the column matrix, and that is equal to our constants. It is also written in column matrix. Now what we have to do is we need to find the I3 value. So to find I3 value we have to take a matrix ratio. Matrix ratio in the sense to find I3, I3 is equal to the numerator matrix. It will be like this. What I'm going to do is I'm replacing the third column of this matrix with the constant. So that is how the numerator determinant is finding out. So 11 minus 3, 15, minus 3, 10, 0, and minus 8 minus 5, 0. This matrix divided by our A matrix. A matrix in the sense this is I am assumed as A matrix. So its determinant. So 11 minus 3 minus 8 minus 3 10 minus 5 and minus 8 minus 5 23. This is the A matrix determinant. So this is how we have to find the I3. Now if you want to find out the I2 value, what you have to do is you have to replace our second column of matrix A with the constant. If it is I1, we need to find out, replace the first column of A matrix with the constant. Okay, this is how the matrix rule is applied. So finding the determinant, we can find out the value of I3. That is I3 is equal to 1.23 amperes, and we need to find the power loss. So to find power loss, we use the I square R formula. So the power loss is equal to I3 square into the 10 ohm. So that final value is equal to 15.13 watts. So this is the current value. So this is how we can solve the mesh analysis using the Cramer's rule. And as I mentioned earlier, you can what uh, uh, evaluate the values by using calculator directly by putting the equations mode and putting the values. Thank you.